Hello again. Today we are going to be taking a little more look again at complex numbers. That's kind of what we're getting to. But now we're going to start to move into how complex numbers connect with trigonometry. We kind of for the past week a little bit more we've put trigonometry on hold with our sine, cosine, tangent, and our triangles and stuff like that. But today we're going to fold that back in. So we're going to say, well, if we have these complex numbers, what does that have to do with trigonometry? That's what we're going to answer today with absolute value and direction of complex numbers. And the thing is, what's really kind of nice about this stuff is that a lot of this stuff, this is directly applicable or directly related to the stuff that you guys worked with vectors in the magnitude and direction of vectors, absolute value and direction of complex numbers. The math is the same behind them. So if you kind of remember stuff from before, this is going to be very, very similar. It's just, the terminology is a little bit different, and the way that things are displayed is just a little bit different here. So complex numbers, the nice thing that we can do about those is we can graph those or plot those points. Although they're not on a number line, they're on a complex plane that works just like graphing vectors, just like graphing points. It's just sort of, we think about them as in a new sort of dimension, right? It's sort of extending our dimension of what we would think that we would have. So like here, if we wanted to graph just the number 3, that'd be over 1, 2, 3, it'd be right here. But if we want to graph the number 3 plus 4i, here's 3, and then we have to push into the new dimension 4i. So there's 3 plus 4i, that's here. And you can see the other ones as well. -2, back up 2, up 1i, plus 1i. -2 would be just on this axis here, right? It'd be right here at -2. Here's -7 minus 5i, that's in pink, right? Because that's backed up, go to the left 7 and down 5. And then same here, forward 6, down 3, 6 minus 3i, that's that spot. And that's all it is to graphing. It's the same as graphing coordinates. You can graph these very, very similar. There are small variations when you're talking about them, but for our purposes, it's basically the same thing, right? When we talk about absolute value of a number, absolute value, all it means is how far is that number from 0, right? So it's really easy when we talk about like the absolute value of -10, we could just count as 10 spaces from 0, or most people say just make it positive, which works when you're just on the number line. But once we move off the number line, then it's a little bit different. But we just say, well, how far is it from 0? We keep that same definition. So here we just take each point and connect it back to 0. And as you guys can probably kind of recognize right now, in order to find the absolute value, we just make our triangle and apply the Pythagorean theorem. So like here, this, the absolute value of 3 plus 4i would have to be equal to 5, because that would be, if we use the Pythagorean theorem there, 9 plus 16, and then take the square root. If we, go around and do each one of these here, we take 2 times 2 plus 1 times 1, and then we would take the square root there. So for example, this one would be the square root, see if I can find that one. Yep, square root of 5 in that case, because that's 4 plus 1, and so on, right? We can figure out all the rest of these here. They're not too bad to figure out. 49 plus 25, right? We'd have to do a little bit of work there, but that's, the square root of 74, right? Any absolute value should always be positive. It doesn't matter what we start with. When you square things, you get positive numbers. So here in this case would be 36 and 9 together, which is 45. So we would say, well, that is equal to the square root of 45 in that case, right? That's 36 with 49. Now you can simplify things if you want to. So, for example, square root of 45 does break down into the square root of 9 and the square root of 5. So you could simplify that if you wanted to and say that's 3 root 5 as well. It's perfectly fine if you don't reduce that stuff. That's okay, on there. But that's how we get the absolute value of something. Absolute value, it's the same as finding magnitude of a vector. It's just, plot the point, draw a triangle, Pythagorean theorem, right? It's nothing too major. It's just a little different terminology, but the math is still the same as what you've been doing before. We're going to go on to one last thing here, and that's the direction of a complex number, and that is the same thing as the direction of a vector, right? We just draw it in here, right? So now I've got the same points, but I just took out those absolute values. We want to first find the reference angle, and we can use inverse tangent to do that. Technically, you could use inverse sine and cosine as well. I find tangent more efficient. So like in here, if I wanted to find this, I would say this is the arctan of 4/3 because this is 4/3, right? And then we just kind of type that into our calculator to figure that one out. And so here, if you guys want to jump ahead while I type these things in there, arctangent of 4/3 is about 53.13, right? Oops, that's not where I want that. Okay, that's where we'll have that one. Let's move this around a little bit. And so here I don't have to actually change it, right? This is the piece that we want. Maybe I can, well, actually, yeah, let's bold that out. That's the piece that we want there because that is, that's the one, like we don't have to make any adjustment. It's in quadrant 1. We can just take that for what it is. It's that many degrees. That's its angle. If we go over to this quadrant, our reference triangle is going to be the arctangent of 1/2, right? Of 1/2 in that case, because this side is 1 and this side is 2. And then we just type that in to our calculator here. So we do the arctangent of 1/2 and find that that's about 26.56. Man, it likes to move that on me every time. So that's not, again, this is not the actual angle. What we have to do is we have to make that adjustment. We have to do 180 minus 26.56 because we have 180 subtract whatever's in this green spot. And that gives us the angle in standard position, right? So then in here we have 153.43. Guess I forgot to round this up. This should be rounded up to 7, right? So that's that adjustment. And I'm going to go around and put the rest of the adjustments in there just in case that wasn't making sense to you before with vectors. If it was making sense to you, you want to go ahead and start the assignment, go ahead. The assignment is attached on Google Classroom so that if you want to type some math stuff in, it's a little bit easier than using the Google Slides. But I'm just going to go through and finish these out. If you want to jump ahead into your assignment, you guys go ahead and do that. So on this bottom one, again, the reference angle, arctan of this case 5/7 because this side's 5 and the adjacent side is 7. We would type that in our calculator again. Arctangent 5/7, 35.54. You can join in there as well. If you guys wanted to type that stuff in, you certainly can. So then here we have to go 180 plus the 35.54, right? That is one thing we do have to do. So 215.54, right? That's what we'd have there. Let's make that a little bit bigger. So we do have to make those adjustments in there. We do have to be a little bit careful about that also, right? That we're making that adjustment. We can find the reference angle. That's very quick. And then we have to adjust by taking away from 180. In quadrant 3, we'd be adding it to 180. And then in this last quadrant here, we'll actually be taking it away from 360 degrees in here. So our reference angle here would be the arctangent of 3/6, right? Which is the same as the arctangent of 1/2. Actually, this should be the exact same thing, 26.57. You can go ahead and type it in there and check. That should end up with the same thing. So now we do 360 minus 26.57. Right, we would subtract those around. My brain's kind of a little bit fried today, so I can't do that in my head anymore. But 333.43. Okay, we would put that right there, and that's the final angle there. So I'm going to keep the ones bolded that are the final answer, right? And we'll keep those ones. So in quadrant 1, you wouldn't have to do any adjustment. That's why I can just put that there because it's just 0 plus that amount, right? No adjustment on that. So that's how you find angle. It's the same thing as working with vectors, exact same mathematics. It's just slightly changing how we refer to it, right? We're just changing our terminology a little bit, nothing too major on that. But if you guys have any other questions on the homework or anything else, let me know. Otherwise, I wish you luck, and I'll see you later.